Welcome everyone. Thanks for joining us today for the World of Discover webinar. My name is Renee and I'm the marketing assistant here at PCS Edventures. But before we get started, I'm going to give you just a quick orientation to GoToWebinar. If you want to go to the next slide for us. Sorry, Renee. Perfect. So right now you should see the slides on your screen as well as Michelle and Grant up at the top there. There's a slider bar that you can move if you want to change the size of either of those views. Also, there's a GoToWebinar control panel on the right-hand side of your screen. Everyone will be muted during the presentation, but we'll be looking out for your questions. Throughout the presentation, type any questions or comments you have in the question box on the right-hand side, and we'll address as many of those as possible during the Q&A segment of the webinar. Just to start, we'll do a little practice. Let us know your name and what you are doing this summer. We'll take a look at those responses and get excited about everything you're doing this summer. At the end of the webinar, there's going to be a quick survey, so please stick around and answer those questions. That'll help us improve our future webinars. So without further ado, I'm going to turn it over to Grant and Michelle. Grant Hathaway studied general science and interdisciplinary studies at BSU before becoming the lead instructor at PCS Edventures Labs. Today, he's the director of Geeko Labs, where students go every day to do hands-on STEAM and digital arts experiments. Michelle is the director of STEM development here at PCS. Since she joined in early 2015, Michelle has overseen our curriculum evolution and product development, making sure everything we create is both fun and educational. Michelle has extensive teaching experience both in classroom and after-school settings and has a passion for STEM education. Thank you both for being here today, Grant and Michelle.
Thanks, happy to be here. So we've got a bunch of great stuff to cover today. I'm going to start by introducing just a little bit about who we are as a company at PCS. And then today we're really focusing on our Discover products, which are all about how can you bring a really student-driven makerspace type environment into any setting. So we'll introduce a little bit of the story, and then we have Grant as a guest here today that can describe how they've taken some of these products and used them in their lab. Yep. So at the end, we'll have a Q&A, so if you have any questions for me or for Grant, you can send those over through the same question panel, and we'll have a chance to address those and any others at the end of the webinar. So to get us started, PCS Edventures has been around since 1988, and PCS actually stands for Pat's Computer School. So we're sitting here in Boise, Idaho, and PCS was started just down the road by a teacher that wanted to teach his kids about computers at a time that was considered kind of crazy. And so to be able to do that, he started his own school and started teaching kids about technology. So fast forward to the future, that became a really popular sort of environment, what we would now kind of call a makerspace. And so for a while, we had similar satellite programs all throughout the Pacific Northwest. Over time, there were more and more programs that were coming to PCS, wanting to see what was going on and how they could take it. So over time, we've also kind of bundled and packaged our solutions and then shared those with sites across the country. So Grant and Geeko Labs would be one example of sites that have taken and kind of made our products their own. So things have changed a lot, obviously, since 1988. But I think one thing that stayed the same, and is true of many of the programs we work at too, our mission is really how do we fuel a passion for learning? And one of the ways we've always done that is through hands-on STEM learning. So as we go forward today, Grant, could you tell us just a little bit about what you guys are at Geeko Labs? What is Geeko Labs?
So we're an after-school STEM lab where students will come and they do experiments with all sorts of things. We cover, everything under the STEAM umbrella.
Can you define what STEAM is in case
STEAM, yes.
Doesn't know?
So science, technology, engineering, arts, and math.
Nice.
So we do stuff ranging from building robots to designing and producing their own music, video games, VR, you name it. So today we just finished up a really cool camp building Rube Goldberg machines. So that was
so fun.
It was fun. It was very fun.
And you guys are primarily an after-school program, is that correct?
We do a lot of after school during the school year, and then we also work with students who are homeschooled. And then over the course of the summer, we just do pretty much like 9 to 5.
Gotcha. So you're doing
labs,
camps and that sort of thing. So you guys do a little bit of everything, which I think means you'll be able to speak to a lot of the people listening today. It's been really cool. In the recent years, we've been hearing from more and more programs that want to do a makerspace-like environment. They may have a really cool lab space like you guys have at Geeko Labs, but they may also be in a K-12 school. They may be in an after-school program. Even some Boys and Girls Clubs, YMCAs are starting to do these types of programs. program. So I think it's been really cool to see that transition. I know Grant can speak to that as we go through.
Yes.
So to tell you a little bit about the products we're going to be talking a little bit about today, all of these grew out of what used to be called the PCS Edventures lab. So this was an environment kind of similar to Geeko Labs, and that students would come and do projects after school, sometimes homeschool, sometimes camps in the summer. But the idea was, how do you provide the resources for students to explore all these different areas and kind of discover where their interests and their passions were? So in all of our products, we try to take what we learned from working in the labs and provide resources to someone who's starting for the first time.
Yeah.
So one thing that you'll see that unites kind of all the different products that we're going to talk about today, they all have kind of a similar curriculum structure that's based on Bloom's taxonomy. So the idea that you start with what we call projects, which is really just teaching, these are the different mechanical components. This is how you build a pulley. This is how you program. I'm sure you could think of some other examples for other areas.
Like here's how you move in a 3D environment.
Yes, these are the
controls
basics.
For the software.
This is how you use a software, just so everyone has an equal footing. Some kids may have been working on it for years at home. Some kids maybe have never seen it before. So everyone gets a chance to learn the basics, and then challenges are, okay, apply that. So you learned how to program a robot, now make it spell out your name. Or you just learned how to do a pulley, now build one that can lift 15 pounds.
Right.
So the ultimate goal, though, in a lot of the programs we work with, is you want kids to work on their own interesting passion projects. So the end design projects and the design projects are designed to be that super creative space of, okay, you learned all this cool stuff. What do you want to do with that now?
Right.
And Grant, I'm sure, has a lot of cool examples of what kids have done.
Oh, yeah. Well, and that's kind of the thing is, a lot of students will kind of lead themselves to that point. If you teach them some cool tool or show them a skill, they're already going to have stuff that they want to do, like teaching somebody to develop video games. They're already going to tell you, like, oh, I want to do a video game that does this. I've always wanted to do this, or I've just got this cool idea. So giving them the freedom to have a say in what they're going to do is really important.
So it's not hard to get them to that final stage. Yeah.
No, it's not.
Do you find it's hard sometimes to get them to do the projects and that baseline knowledge level?
I would say that those, especially for students who do have somewhat of an understanding, they have a hard time, buckling down and saying, like, okay, we're going to do this. You may know some of it, but it's important to understand all of it before progressing. There are students who don't quite want to or want to get to the fun stuff, especially in an environment at Geeko where you have students who are working on really cool projects that are advanced. Younger students want to jump right to it.
Right.
They want to just fast track.
And one of the cool things I feel like I've seen that you guys do really well at Geeko Labs is you use that, right? It's like, okay, you want to do that really cool thing. This is how we're going to get you there.
Yeah. Well, and it works really well to do something in reverse to take, say, here's their end goal that they want, and then to break it down into those fundamental concepts to what would be a project. Saying, all right, if you want to build, this machine that does X, Y, Z, to do X, what do we need to build? And then they're like, oh, I don't know. And then you tell them, well, let's break it down into smaller pieces until you get all the way back down to the bottom. And then they see like, oh, okay, like now I get it.
Now I see why we're doing
there's a reason. I'll just crank this out really fast. And then it obviously takes longer than cranking it out really fast, but they at least start on that path and get invested in it.
Yes, yeah, exactly. It's not just like, okay, we're going to learn CAD. We want to create the super awesome thing, so I have to learn these skills.
Yeah, CAD's a good example too, because they always want to 3D print something right off the bat. It's like, okay, let's get started. And then they don't know how to move. So that's why you start at the basic level where it's like, here's how you control the software.
Yeah, which they maybe never would have been drawn to without that end goal. And so I think that's one of the things that's really important with the Discover is it's not about the skills, it's about the end goal. Like, where can those skills take you?
Yeah.
And you guys do that really well. So we've already hit on a couple of these, but one of the other things that unites all of what we would call Discover is that it focuses on new technologies. So we've mentioned some. CAD, 3D printing, not necessarily all of these are within the Discover umbrella. What are some of the ones that you use in your lab, Grant?
So we use, so what are the new technologies? So we use 3D scanning, VR development, video game development. We do have some drone stuff. lots of coding, web design, and we stick to the basic engineering things. That's not a new technology, but that one's always really fun. And then Arduino, we do a lot of cool robotics stuff with Arduino.
Nice. And I think those last two ones, you use some PCS materials.
We totally do.
Correct?
We use the Fisher Technic and all the building materials that are in the Discover stuff for the engineering. With the Rube Goldberg stuff that we just did today, it was all Fisher Technic, which is fantastic.
Can you tell us a little bit about that, what you guys have been doing this week?
So the Fisher Technic Rube Goldberg camp is designing and building a Rube Goldberg machine using all real life mechanical actions based off of simple machines. So we did pulleys, talked about how you can create a mechanical advantage using different amounts of pulleys, and then incorporating that into, what's the input, what's the output, and then we moved on to levers, and you can do all of that with Fisher Technic. Like, there's no end to what you can do in building stuff with the Fisher Technic. It's really phenomenal.
And if you haven't heard of Fisher Technic, if you see the picture on your screen, Fisher Technic is a set of building manipulatives. Mm-hmm. And Grant, how would you describe the difference between Fisher Technic and maybe like Lego?
So number one, Lego, uses a snap system with the studs, and there's not anything like that in Fisher Technic. What a lot of kids will compare Fisher Technic to is like Connects, where there's more that you slide the pieces together, or you can attach them in different ways. They're different than those because you can actually use like a dovetail groove or a rivet system. You use gears, you have real world mechanics like pneumatics, chain drives, you can use solar panels. And my understanding is that Fisher Technic is actually made by another company, a company that does industrial fasteners too.
Yeah.
That they like know their stuff, and so they built this so that kids had more real world examples than say Legos or Connects.
Yeah, and Fisher Technic, I learned recently, they actually build models for commercial companies. So if Google, for example, is building a new production line, they sometimes will ask Fisher Technic to build the model. So this really is like industry grade building material.
Yeah, so that's new information to me. That's really cool, and I believe it because you can do so much. Like we had somebody do a sorting machine that uses infrared sensors to like detect the color and separate parts.
Well, and that's another really good point. The Fisher Technic can integrate really well with robotics. Mm-hmm. And so this would kind of highlight one of the points there to go back to kind of what unites all of the Discover. All of our Discover kits kind of come with a set of materials like the Fisher Technic or the robotics, and then a set of curriculum kind of activity cards that outline a whole bunch of different activities you could do with the materials. But the goal for all of them is that even once you've gone through all of those activities and learned how to build or how to program, that then you could use those materials over and over and over for different activities like Goldberg machines. I mean, you could probably give a lot of other examples too.
Yeah, you can do like sumo robots that, you keep them in a black circle. They use infrared sensors to stay in, and you do a little competitive game where you try and get the other one to disable or push the other robot out, which is a really cool, it's a cool lesson in gear trains and creating torque and keeping traction and using the sensors to detect where things are. So,
and that would be like that applied example again. And this is where maybe you could come up with your own extensions, but ideally your students are also coming up with their extensions.
Yeah, so we had a student who came up with this idea that he wanted to have something climb a wall, just vertical wall. So we designed a big robot that was really flat that had suction cups, and he actually ended up locating some on his own and integrating it in with the Fisher Technic and building it in using the pneumatics and some of the other mechanics pieces. You had worm gears driving the pneumatics to create the suction that was strong enough to stick to the wall. You had actuators that were motorized to lift the suction cups. I'm trying to be the robot. It had like two hands. And so it would raise one and suction to the wall, and then lower it and raise the other one and suction to the wall. And it climbed a window, and the thing was, a foot long, probably weighed 2 pounds, like total, and he did it all all on his own, really.
And this was all with the materials from
All.
Discover Engineering, Discover Robotics?
Yep, everything in there. Because he used the brain, he programmed it using Cortex. I'd say the only thing that was not was the super glue that we used to stick the suction cups to another piece, and then to get this, and then the suction cups themselves.
Nice.
But yeah, everything else was there.
We're getting a little bit ahead of ourselves here, but you mentioned a couple things in that description, Cortex and the brain. Can you break down what those are?
So Cortex is a programming environment that it's kind of I call it like a mask over Arduino. It does some really cool stuff that's just all visual programming. So if anyone's ever used Scratch, it's like Scratch, but you can use it to program the brain, which is a microcontroller that is compatible with Fisher Technic parts.
Nice.
It's really, really great for students who are young. There we go.
Yeah. So here's almost all the way built. We call him RIQ would be the robot, and then this would be the brain right here.
Right. So it's really capable. It's really easy for young students to learn to use. Excuse me. But it's also advanced enough to where you can go in and create procedures and functions and do anything. This is what was used to create that sorting machine. This was what was used to create the wall climbing Spider-Man robot. But yeah, it's very user friendly, and it's a real blast. Like once you get the hang of it, there's so much that you can do too.
Yeah. What's the age range? So like how old are these kids? How high can it go? So
we work with kids who are between the ages of 9 and 17.
That's a range.
Sometimes on a case-by-case basis, we'll take like 8-year-olds. We've had kids as young as 7 work with that. Wow. And really it depends on their reading level. If they have a reading level that they can look at the commands and read the commands, then they're set.
That's awesome.
It's really fun to have, a 9-year-old come in who wants to learn coding or robotics or something, come in, work with these materials, and have the ability to produce a robot that can navigate and move and call different procedures based on different sensory inputs. Whereas, you don't get this cool stuff like that until you're like maybe I know some high schools have programs like that.
Right.
When I was studying at BSU, we did some stuff with Arduino that didn't go too deep into it, but as far as giving them an opportunity to really get excited about creating something and find a passion for it, it's fantastic.
It's that hook. Have you seen that your students have then gone on to pursue those careers and those passions?
So one of the students who I worked with for a long time ended up coming back and wanting to work as an instructor at Geeko. So one of my students is now one of my employees that we work together on building stuff, and he did lots and lots and lots of stuff with robotics. He built a robot that could navigate and kind of map out a room almost. It tracked its location using variables to kind of create a space on like zeros and ones on where stuff was and where stuff wasn't. So you ended up with like a 2x2, not a 2x2, but like a 2-dimensional grid that had like 0, 1, 0, 1, 0, 1, 0, 1, 0, 1 of where stuff was, which was crazy. Like I don't know if I could do that in the amount of time that he did it. It was so cool. But that's one of the cool things about it is there's no upper limit really.
Well, and that's like the goal. You want them to be pushing their own boundaries, like finding their own applications. Yeah. And that's really what we mean when we say student-driven exploration. That the goal is all about, okay, what are you interested in? Like you said, what do you want to do? And we'll support you in getting there. You also mentioned the reading level. Can you talk a little bit more about why that matters, especially in a student-driven space?
Right. So in our space, we have a lot of our projects are written out for the most part. It's very visual, it's very graphic, not very graphic, there's lots of graphics, but there's just some stuff that they got to read, and especially with Cortex, when you have to be able to like type in the name of a procedure, or you have to like look through and read from top to bottom what the code is really going to be doing. If they don't have the reading skills to do that, then the other option is to have an instructor say everything and read it to them, and that's just not not feasible in most scenarios, unless it's like one-on-one teaching. But I don't think that anybody,
skills.
I mean,
You know, like it's a cool application of all this technical reading and writing, but this is a big shift. We hear from a lot of people that are shifting into makerspace for the first time. It's not so much like, you know, here's the instructor leading the class on this, doing the whole PowerPoint. So all of our curriculum that comes with Discover is purely student resources. So there's no slides, there's no worksheets, there's no even kind of like okay, here's what you do for the first 10 minutes, here's what you do for the next 15 minutes. It's all, okay, here's your resources for your students to learn the information they need, which is a shift. But you think about when you go out into the real world, that those are the skills you need to actually be able to learn for yourself.
You got to build up that investigative kind of mentality. And so if they can't read, then it's going to be real tough. I've got students, well, actually my son, who's 7, he just finished 1st grade. One of his big motivators to learn to read was I told him that he couldn't learn any of the cool stuff that we do at Geeko unless he knows how to read. Once he learns how to read, then he's totally welcome to come.
So, and that's so important of like what STEAM can be for kids that maybe aren't super into reading and writing, but if this is the thing that motivates you to actually do that, that's a huge win.
Yeah, especially coding. Especially, you just can't.
You got to know your alphabet. So can you talk about, I mean, how do you guys make that work? Like, what does that look like? I'm sure it's not a traditional, okay, everyone sit at your desk and we're going to do this lesson. Like, what does it look like to teach in that kind of environment?
So at Geeko, we have students come, we do about a 5-minute, a quick modified scrum, which is just a stand-up meeting where each student has a chance to have accountability on what it is they did last week, what their goals are, and then we not hold them, strictly to those goals, but we work with them to achieve those goals. Then after that, we have an hour or more where they get to work on individual projects. They get to pick what they're doing within the curriculum that we have available, with all the materials that we have available. There's a very low student to teacher ratio. We cap it off at 4 students to 1 teacher, and a lot of the times it falls down to like 3 students or 2 students per, which is great because they get a lot of hands-on help. They get immediate like questions if they need it, which I think is really important for a makerspace to give them independence, give them freedom to do stuff, but to be available to jump in right there. And that's so being like a coach or a mentor really is the key, and that's what we try to do. And then for that hour, 15 minutes that they're in lab, they get to pursue stuff on their own. They ask questions, they brag to us. We are there for their exciting moments when they have little victories. We're there to challenge them a little bit more if they kind of blow through something and it seems like it was too easy for them.
They need the next thing. Well, and I imagine you have a really strong technical background, right, with your degree of being in lab. How important is that to being an instructor in that space?
If you don't have a good understanding of what you're trying to teach the students, you can run into some really awkward problems. Like, hey, I ran into this thing, I don't know how to fix it, or I can't troubleshoot, this robot. Some of the things, we do have some instructors who are newer, who don't know how to problem solve, say like working in a Unity video game development environment.
Right, it's very technical.
It's very technical. There's a lot of moving parts, and for students, for the students, if they ask an adult who's there, who they're supposed to look at as a coach and somebody to help them when they need to help, if they either A, don't know, or B, steer them in the wrong direction, then they lose a lot of trust in the adult, and it's discouraging for them. For sure. So knowing your stuff, I'd say is as important as being well equipped and having stuff.
Yeah, well, I think as teachers, we tend to be so focused on our students, right? But that investing in yourself to, go through the activities yourself totally does pay off.
Yeah.
Now, that said, I'm sure you always run into those situations. How do you coach your instructors? Like, if you do run into that, like, how do you manage that? What do you do?
So for any instructor, if we run into a problem that's over our heads, because I mean, I've been doing this for years and I still run into stuff.
Yeah.
Like we have advanced students who know Blender, which is a 3D modeling software,
Right.
way better than I do.
Yeah.
And they'll come in and be like, hey, like this is my problem that I'm running into. We just walk through the troubleshooting process with them. We investigate with them and show them how we would solve that problem, or how we're going to solve that problem, and how to approach that without being flustered or frustrated.
Right, you're like modeling.
Persistent, yeah. We just say, all right, I'm going to be a student with you right now.
Yeah, and you can be
figure this
upfront
out.
about that. Like, I don't know either, so let's go through and figure it out.
Obviously, the better option is to always know what the answer is and kind of help lead them to that. But if you don't, then model what it's like to be a good student.
Yeah, and I think that is important for them to get to see adults of like, okay, like nobody knows everything.
Right.
Everyone's going to have to learn something. I come from a science background too, but I think it's awesome for kids to see that when they ask a question you don't know the answer to, that you're like excited about that because you want to go learn something new.
Yeah, and that's one of those things. If they can see you try and problem solve this with them, that's another way that they can kind of gain some trust with you.
Yes.
When you don't know.
Yes.
As long as you're being honest and a little bit vulnerable with that whole, like, I don't know, let's do this.
Right.
I'm really excited to find out what this is.
And this is going to be okay. It's actually going to be awesome.
Yeah. Which is really good when they are running into a problem that is legitimately frustrating.
Yeah. It's like, I understand why you're frustrated. We can work on this together.
Yeah. Yeah. Sometimes you can tell, like, oh, like that. I had a student who was trying to do some texturing in Blender, and not just texturing, but doing a really
What is Blender?
unique Blender, the 3D modeling software Blender. And they were trying to essentially paint their model using this really unique method that created like multiple layered textures within that they could change through in the video game. So end result being their player could change colors in game.
Oh, so they wanted their player to be able to change colors.
But like using the same material.
Okay.
Like really complex stuff. Could not solve it. Didn't know what was going on. They were super frustrated, and it was just like, yeah, like I'll sit here with you in this, and we'll figure it out. And I can totally see why that's frustrating, but we will find a solution. And how, like, what a cool thing to end up knowing how to solve. We ended up solving it.
Yes.
It ended up being a lot easier than we ended up thinking it would be, which is the case a lot of the time. But just being there, being in it with her, and telling her, I don't know how to do what you're trying to do. This is new to me. Let's attempt a couple things. Let's experiment with this. It's gonna be really cool when we figure it out. Yes. Took her from being like almost at tears to really, really, really proud of the fact that she was able to overcome that knowledge gap, discover something new, and to create something that was really, really cool.
Yes, like what feels better than like overcoming a big challenge? Like when you solve the problem. So you're like validating, like, no, this is like a real thing you're working on, and we can go through it. And that's where, we hear from a lot of people that say, like, I don't have a technical background. Like, I don't know about robotics. I don't know how to do coding. Like, am I going to be in over my head? And I think what you say is really true. Like, invest in yourself. Like, go through the activities, give yourself time. But also, like, it's okay if that's not you and you're going through some of it with your students and learning with them. Yeah. And sometimes we even hear from teachers that say, you know what, my students almost became the experts, and then those kids that know a ton get a chance to share that.
Which is really, really powerful too. If you ever have students who are very well versed, one, it helps them to kind of reinforce that knowledge by teaching it.
Yes.
They get some really awesome confidence in that experience. And then two, they're also a resource for the teacher, to be totally honest. Like
it's a legitimate thing.
I have students who I will, like, I'll have a question from the previous week that I just saved, and I'll ask my student, one in particular, I ask a lot of questions about Blender too. I'll say, hey, how do you do this?
Yeah.
And they'll show me, I'm
need
like,
to.
awesome, thank you. I'm gonna give the other student this information, and it works well. Like, they actually exchanged emails, so now that they're working on a project together too.
Yeah,
which
and
is
that's
great.
like, it's the goal. You're like supporting a collaborative space,
Yes.
right? And so this is my next question for you. All of our kits come as a single set of materials. So a lot of people are used to maybe like a classroom set, but everything that we send out is meant to be really modular, knowing that a makerspace could serve, 3 kids or 100 kids. So how do you guys find that balance in lab between individual projects and like also small group work and collaboration?
So the majority of what we do is all individual work, and we get some collaboration as students stay a lot longer. So we'll have, one student who's been working on something really cool in Blocksmith, which is a really awesome VR builder,
Yeah.
like a game development environment. It does to video game development what Cortex does to robotics programming.
Cool.
It's like Scratch meets Unity. But it's a really cool program, and some students who are new will be working on stuff, and other students who've done Blocksmith might be working on something different, but you'll see something pop up for the newer student, and one of the older, more experienced students will come over and be like, hey, I ran into this when I built my game, and they'll pull up their game and say, like, this is what I did, and this is how I'll fix it. So having materials there and just being able to support students to get more experienced in it is one way to bring out collaboration.
Yeah, that's true.
I really like the whole idea of being able to have students work on other stuff. That's kind of hard to facilitate if you're running a really small program. You have more options than there are kids, then you need to know a whole lot of stuff, and you might not need to. But the more you can get students to that advanced level, the more collaboration you're going to see, because that brings up opportunities for them to troubleshoot on their own, to have a better understanding and instrumentalization of the material, so that they can just kind of think, oh, hey, I could do this with this stuff.
Right.
Whereas
like
it's
combining.
Yeah, the other side of that coin is if you have a new student who comes in and looks at all the robotics things and says, I want to build a walking robot, that's so cool. And you're just like, no, don't.
We'll get you there, but maybe in 5
like,
years. Yeah.
Really, like, the amount of sensor and programming that would go into a self-correcting walking robot. And it's hard to explain that to a kid who's really young. Same thing with 3D printing. If you're like, come in, like, yeah, we can start 3D, learning how to 3D print. They're like, awesome, I want to make, this thing that has comes out in full color. And you just have to kind of bring them back to, okay, hold on,
we're gonna start here.
We only print in one color because that's how filament works, and then also we need to learn how to model something before we can actually print it, and all these other things. So in terms of creating collaboration, I'd say yes, it's the advancement of the students that causes that. From there, you can kind of almost hand stuff to them, be like, hey, I want this from you for.
Figure this out.
And we do have an advanced group now where only students who have gotten past a certain point in our program come. They don't even work on learning anything anymore. Now it's just building stuff. Their goal is to produce something.
They have to apply what they've learned.
Yeah. It's not quite a you've made it, but it's here now you have an opportunity and the skill set to really create stuff.
Yeah, and you want to keep pushing them. And that's important too, because so many sites have mixed age groups, and that can be a challenge, but like you're saying, it can also encourage that collaboration.
Yeah.
And I know you said you have a lot of your students work individually, and that's, I think for a lot of us, the goal. We've also seen lots of sites say, okay, we're going to work up to that, but as we're getting started, maybe we have enough materials for students to work in groups of 2 or 3.
And having them start on the same thing, pairing them up to do a project is totally viable. Like having 2 students troubleshoot a robotics issue is a lot more effective in terms of time if you have short material, or if you're short on materials, to have them do that together, and then it builds relationships.
Yeah, and then they got to communicate, work on, all that good stuff that comes from having a partner. I would think also would carry over. So we've talked a ton about the student-driven, the maker space, about how versatile it is. You guys are in an out-of-school space. Do you guys try to teach to any standards, or are you guys pretty independent?
So we're really independent, and we get a lot of flexibility in what we do because we're a for-profit business technically. And what we focus on is building up skill sets that would be marketable. So learning the ins and outs of Blender and really becoming proficient in that.
And in industry standard software, right?
Yeah. So if they are learning the industry standard software, industry standard materials, and that's kind of the approach that we take by using Fisher Technic, because we have students who they build their own engines at home and come here and apply the stuff they know at home to building.
Right.
Somebody builds an internal combustion engine using the pneumatics.
So cool.
Obviously, we don't do any explosives or fire, but they built a working internal combustion engine out of Fisher Technic. And so in that way, those are kind of it's proficiency in the material, in the software, or in, if it's robotics, in producing something.
Right.
And that's where they really gain that confidence. And then that's where we send them off to working in an internship or
Yes.
trying to find a really cool degree program that works with them.
Yeah. To make that transition into what comes next. And that's all of our curriculum materials are aligned to 2 frameworks. One's called 21st Century Skills. So it's kind of the collaboration, the critical thinking, those sorts of broader skills. And then also habits of mind, which is some of the things you mentioned talking about the troubleshooting. How do you persevere? How do you pay attention to detail, which in an out-of-school space you really can focus on. One of the things we hear about a lot is people are bringing these types of environments into, say, a classroom. It's a different sort of reality. And so while all of these were based kind of in that framework, if we want to prepare kids for the future, we also understand that if you're teaching in a classroom, you've also got to be aligned to national standards, and you can do those at the same time.
Yeah.
So we provide, yes, you're teaching to a technical reading standard, or you're teaching to a math standard applied here.
Yeah.
So that it can do that crossover, knowing that the out-of-school space has a lot of freedom that maybe you don't necessarily have in the classroom.
Yeah. Well, and even then, in terms of teaching the standards, you still have all these materials that you can use to kind of adapt and cater it to, if you want to teach to those standards in your own way.
Yes.
There's a whole lot of resources there for you.
Right. Well, especially you were talking about the pneumatics. So our Discover Robotics and Physics curriculum is all using the robotics, using the pneumatics, but instead of having a robot in our IQ, you might have a race car or a catapult or a marble launcher.
Which pneumatic catapults
are
one of the coolest things I've ever made.
Yes, I think we do recommend catapulting gummy bears, which may be a little controversial, but it's really fun and it hits on a bunch of different physics standards that you would need to hit in like a science class setting.
The Fisher Technic does come with marbles. I don't suggest catapulting marbles.
We don't suggest doing those ones. No, maybe marshmallows.
Just if anyone had those ideas,
Yeah, no, I'm sure a student will have that idea. So to kind of wrap up, I think we've touched on a lot of these, but kind of the overall goal of what we try to accomplish with our products is how do you provide resources to kids to help to discover their passions? Like Grant listed off all the different areas that they get to explore in lab. So the goal is expose kids to as many different things so that they can decide, am I into engineering? Am I into robotics? Am I into the science? That might help them as they're going forward, but also the STEM skills and the soft skills. Like, what are they going to need to be successful when they get into industry?
Yeah.
And then the last part is, they're all designed, so that this could be easily adapted. Maybe you're in a library, maybe you're in a 21st century community learning center. How can you take this and then have someone look at the materials, learn how they work, and make it their own like you guys have?
Yeah.
So we've talked about a couple of these, but I wanted to show you a snapshot of this is where Grant works in the Kiko lab. So Grant, you're going to have to tell us a little bit about what's going on in this picture.
So this one is actually the old Adventures lab.
Oh,
this one is in Boise. So in this one, they're building a drone and testing the flight. I don't see who has the controller, but doing a quick flight test on drones. I remember that we would do something about drone dynamics, which was pretty risky inside the building.
Yes,
But there
we don't
are
recommend
some
indoor flights
some
with the
guards
drones.
around the propellers
true.
there. But yeah,
We won't touch on drones too much in this webinar, but if you are looking for information about drones, there are tons of other webinars that go into great depth about drones. We did want to touch on some of the products that you guys still have in Geeko Labs. And so a couple of these that we're going to talk about, we have put in what we call a Discover STEM Lab. So you can see in the previous picture, you know, in a perfect world, you'd have this whole space and you'd have all this storage, but a lot of programs when they're first starting want something a little bit smaller to try different things out, get a feel for it. So that was the idea behind the Discover STEM Lab. So it has 4 different modules or kits, which are basically a set of parts for one kid or a group, your whole curriculum, so all these different activities that you can do with the parts. And then the cool thing with these ones is that, like Grant said, they all work together.
Yeah.
So you could take your Discover Engineering Fisher Tech parts and combine it with the brain from your robotics and programming, and then maybe use the solar cells and renewable energy. And we heard from one side that built like these solar houses that were all robotic and had different programs. So design that they can all work together. That Discover Dynamics would have what you can see here, a lot of roller coaster parts, so you get some more of those structural elements. So I wanted to look specifically at Discover Robotics and Programming. You already introduced to us, this is Cortex and the brain. So do you have any other stories of kind of what your kids have done in lab with these materials?
so we've had countless things. The cool thing about Cortex and Brain combined with Fisher Technic is you can really do whatever you want with it. With just a little bit of Fisher Technic, it gives you a whole array of things that you can build that's mobile. With a lot of Fisher Technic, you can create and design, you know, structures that have sensors that react to things. That was one of the sorting machine was a pretty big assembly line style robot that had all, you know, wires coming off of the brain into every different spot. So it's not a robot in the sense of how people kind of think of this anthropomorphic, mobile, moving, self-contained robot. It was a big structural and thing. And so that's one example that stands out. There's been students who have done robots that are mobile, that are big. We had a student do this like a tracking robot. It would follow you.
Oh, like it would follow a person?
It would follow a person.
What sensors was it using?
They used the infrared sensor and they used the ultrasonic sensor, and then it would only work when it was really, really dark because it would do lights, and then they had multiple ultrasonic sensors to detect, like if it needed to turn, it had them kind of at an angle, so it would try to keep the person in the middle and it would point them up. It'd get a little bit messed up when you got near a wall because it would like detect. They're like mid troubleshooting, like having if all the sensors are below a certain limit that it's too close, and it would like kind of turn and scan. But there's a lot of options. We've had cool like tightrope robots. We have maze.
What do you mean by a tightrope robot?
Like a robot that is on a tightrope that just kind of goes back and forth forever using sensors. Which is kind of cool.
Like a pulley wheel almost?
Yeah, it just has like a motorized, it's a wheel that just goes back and forth. The maze navigating robots are my favorite because it is mobile and it's using sensors. So there's a maze that's, you know, you close the lid on and they go in and they have to get to the end using sensors. There's colors in there, but it's dark, and that's a fun one.
A bunch from there. I think you can max it out at 7 different sensors.
You can do 7 sensors. You got 4 DC motor ports and 4 servo motor ports, which servos are the best. What is a servo for someone who doesn't know? So a servo motor is a motor that can detect the angle at which it's at. The servos that we use operate between -90 and 90 degrees, so you have 180 degrees of motion there. So this gets you almost like an arm motion. Yeah, so it operates like an elbow. Yeah. And if you do 2 of them together, you can create like a shoulder joint. And so building a robotic arm, like a 3-axis robotic arm, which is one of the most common things in robotics, any assembly line probably has one of those,
robotic, yeah.
we can build that, and we have. Like we've done it using servos. We've done it using pneumatics, like a pneumatic powered 3-axis
You start
robot arm.
combining those together.
Yeah, it is really, really cool. Robots that can climb up ropes with heavy weights.
So to do some of that, you're definitely going to need to go beyond the Fisher Technic parts that come with the RIQ,
With
the
RIQ,
Discover
yeah.
Robotics and Programming. So this is another one that would have a lot of the different elements that you've mentioned.
Yes, and I would say that the more Fisher Technic that you have, the more creative freedom your students have. Like it's so much more valuable to have a lot to draw from than to say, here's what you got, see what you can do with.
Right, here's your predefined builds, and that's all you can do.
There's a lot that you can do, and that does cultivate some creativity because there's a limit, and they have to kind of come up with cool solutions. But it does expand it quite a bit by being able to build and design with more.
And with a diversity of parts is I think one of the things we try to do too. So with engineering, you get a lot of these mechanical pieces.
Yeah.
With the dynamics, you get more of the structural. With the solar energy kit, you're getting those solar cells, which opens up kind of new types of power.
Which we don't have any solar stuff.
You're gonna have to get some.
I know, solar stuff would be cool because then you have a self-contained thing that's just, you don't need to have a battery.
Right, just go forever. You can like put your boat in a fish tank and lab and let it go.
Yes.
Yes.
Let the little tightrope guy he's by the window, let him just run forever.
And then like start talking to each other. There's so much you could do.
One student found a way to get 2 of the brains to communicate with each other too.
Oh my gosh.
Yeah.
I don't think we have time to go
Yeah, that's a whole
one.
rabbit hole. Man, there's so much that you can do.
Yes, so we've gone really far into the kind of most advanced extensions you can do. But the last thing I want to talk about before we have time for a little Q&A at the end is we also have a version of this that works better for younger students. Because I know you said 9 is kind of your lowest limit, maybe 8. But we hear from a lot of people that say, I'm working K through 5. Like I have younger students and I want to get them started. So that was the idea behind the Discover STEM Lab. So this one doesn't have any Fisher Technic. We find the younger kids find it kind of frustrating to get the pinning groove system. So this one includes our bricks, which are Lego compatible, and our Brick Lab Zoology curriculum. So all of these also are really student driven. But at a much, simplified, grade appropriate reading level so that students can go in, build a bunch of different animals, learn about their adaptations, and then start using the bricks for open-ended engineering. This one includes a mix of different materials. So the next bin would be your digital video lab. So they have a tablet, they can record what they're doing. And then for the Cubelets, I think we have a picture of this one. So with the Discover Video Lab, they would have a bunch of different videos that they could create. You could also use that same tablet to work with your Cubelets. So these are like a very simple pre-RIQ, pre-Cortex. If you want to introduce those same concepts to really young kids, these are all magnetic blocks. So they come together, but they have a battery. And when you power that battery on, some blocks are sensors, so they can maybe tell how close you are or what the light level is. And some blocks are actions. So that action might be a light or it might be wheels. So you could have like a flashlight bot that turned on when it got dark, or you could have like a Jedi mind bot that as you moved your hand closer, it would run away from you. So it's a really cool way. Even we've done it with kids pre-K, can use these blocks. They're super durable, but it's that same input output that builds up to this. And then you could program them in a drag and drop environment. You wanted to transition up to kind of some of the things that Grant was talking about. So these are in the 3-4 curriculum. This would be that full list of all of our Discover products. So we talked about the STEM Lab for 3-4, the STEM Lab for 5-6. All of those bins are available on their own. So the idea is you can kind of mix and match, create your own makerspace type lab. And then there's also an advanced Discover Robotics and Programming curriculum. So if your students want to do some of the really advanced stuff like Grant was talking about, there is some support for that, which gets really cool. So I know we're close to the end, but I want to be sure we have time for some questions. So feel free to send those over in the question panel for Grant about what they do at Geeko Labs, about products, or anything else we can help you with.
Yeah, definitely. So we have 2 questions to start with here. The first one is for you, Michelle. So you talked about some of these Discover products. What environments are those most commonly found in?
Yeah, it's a really good question. I would say the thing that unites them is they're a makerspace type environment. So there are a few programs like Geeko Labs that are kind of a standalone, but I would say more often we see people in classrooms, libraries, after school programs trying to create that kind of space.
Very cool. And a question for you, Grant. What advice would you give to someone if they're trying to start a STEAM lab in their school or a makerspace, turning that class or that school library into a makerspace? What advice would you give to them?
So I would say the most important thing is going to be being well equipped, having the material, because it's really difficult, one, to get it started, and you don't want to run into the problem of you get kids to actually come and want to participate, and they're excited, and they get there and they run out of something to do. That is the worst feeling. So you want to have, a menu of things that's there. Even if you're going to kind of go through the same stuff, make sure you have enough, and then make sure you know it, because that's going to be important. Those are the two driving factors that are going to make their experience better and make them want to come back and really actually get something out of it.
Yeah, and have a really positive experience.
Yeah.
So those are all the questions that we have so far. If anyone has a question we have not yet answered, please feel free to send those. Even if we don't have time in the last couple minutes here, you can ask those in the survey at the end, and we'll get in touch with you to answer those. Grant or Michelle, are there any last comments you want to add about Discover or about things you're doing in the lab coming up?
If people want to learn more about Geeko Labs, what should they do?
Go to www.geekolabs.com, check us out, like us on Facebook. We're pretty fun on Facebook. We post a lot of really cool things that we do there too.
If you're in the Treasure Valley area, come check them out.
Yeah, that would be awesome. Take walk-ins between 2:30 and 6:30.
And I would say the same for PCS. If you're interested in seeing any more about these, all of our contact info is there. And I guess the last thing is to not be intimidated. We've seen so many really cool success programs like Grant, which is really cool to be able to share with everybody.
Awesome. Thank you guys so much. Thank you to all of our attendees for joining us today. We appreciate you being here, and a huge thank you to you, Grant and Michelle, for your insights and your time with us here today. To all of our participants, as we end, remember that there will be a short survey that comes up on your screen, so please do take a minute to answer those questions. They really help us to serve you better. Also, within 48 hours, we're going to share the video recording of this webinar, so you can rewatch it or share it with any of your colleagues or friends who might find it useful. Thank you again for joining us, and we hope to see you next time.